Welcome back, geology fans. Where, what, when have all been covered, and now it's time for the why. Why does the Earth have the landscapes that it does, and the rock formations making up those landscapes? Why are the mountains of the world where they are, and why do we get volcanoes and earthquakes in certain areas more than others? As climbers reach the top of Mount Everest, they hit what they call the yellow band. The yellow band is a bed of deep, marine limestone with marine fossils on the top of the world. Tilted, twisted, folded rock tells us the surface of this earth has been in motion, and displacement due to earthquakes and volcanic eruptions tell us it is still in motion at certain places in intermittent times. Early geologists knew these patterns and posited various explanations. A 17th century monk suggested that America and the European Old World were once connected through the fictional land of Atlantis, but the biblical flood separated them. In the end, some land bridges were found to have existed when sea level was lower, but certainly not across the mid-Atlantic, and Atlantis was made up by Plato, and so is completely fictional. And biblical flood. By the 18th century, there were ideas of the crust floating on a denser liquid below, and that movements of the liquid would cause seashells on mountaintops, and the other evidence of crustal movement. Again, this liquid interior Earth did explain some features, but left many others with a lingering question mark. Lamarck, of more biological fame, suggested that continents eroded on their western side and deposited on their eastern side, and so they seemed to migrate across the globe like a stadium wave. Again, this did not find the supporting evidence. And by the 19th century, geologists had conceived that the slowly cooling Earth is maybe shrinking like a drying apple, making the mountains and valleys of the world. But then why were there places that showed extension, pulling apart of the crust? A dried apple or thermally contracting sphere doesn't do that. None of the explanations fit all the observed evidence or even a majority of it. The why of Earth was still a mystery as the 20th century dawned, and a meteorologist by the name of Alfred Wegener finally started down the right track. There is so much to say about Dr. Wegener. Born in Berlin, fought and survived the front lines of World War I, married the daughter of Köppen, of the Köppen climate classification, and was a friend of Muten Milankovitch, whose orbital cycles we briefly mentioned in the last episode. Wegener's main scientific contributions, he thought, were to better comprehend polar atmospheric motions, and he laid the foundations for understanding the jet stream. To this end, Wegener spent several seasons out working on the Greenland ice sheet, and noted how something that looked massive and static was actually in motion. Perhaps this primed his mind to see the continents of the Earth as being even more massive and a bit more slowly but surely in motion. Much of what Wegener pointed out had already been noted by others, but he did put it together with the best complete argument in a theory he called Continental Drift. The idea of continental drift was that the continents of the world are in motion, moving like the icebreaker ships through brittle crust of the ocean floors, and the evidence for this was that the continents were once joined together in a giant supercontinent Wegener called Pangaea, literally meaning all Earth. The evidence for Pangaea, in turn, was multifold. First, as many others had noted, the edges of the continents look suspiciously like matching puzzle pieces of a jigsaw puzzle. South America can nestle in with Africa, and North America and Eurasia can be brought down and join Northern Africa, and so on. Wegener went further than others in noting that when these obvious edges are actually matched together, you get some very interesting patterns that further imply former unity. Older structural features like areas of past compression or extension or mountain ranges that end abruptly at the eastern side of South America continue across to Africa when joined back together. Similarly, rock formations, valuable mineral belts, and certain fossils in the rocks continued from one side to the other. Being an expert in glaciation, he knew how to read scour marks for glacial action and showed that there were glaciers in Africa moving to the west, and these same scour marks continued across to South America with the same consistent flow to the west. He said, It was as if you had two pieces of a torn newspaper, and that if we were able to match them at their edges, and the print then reads cleanly across the break, then there is nothing left to suppose but that those two pieces were once joined together as one. Pretty convincing argument. And it certainly led to some new thoughts by contemporaneous geologists and geophysicists, but the geologists took issue with the Continental Drift model of continents plowing through ocean crust. For if the ocean crust was weak and the continent strong, then why do we find failure and crustal shortening along folded and compressed mountain ranges on the continents, and not below or sticking up out of the oceans? And the geophysicists asked, what's the mechanism for this movement? Wegener thought the tidal pulls of the sun and the moon were at play, pulling the continents through the ocean crust. But it didn't take geophysicists long to tell him that this was an absurd idea. We'll guess that it wasn't the shock of this rejection which led to his premature death of a heart attack while out on the Greenland ice sheet as the 1930s dawned. Wegener was the leader of the 1930 expedition to Greenland and was caught in a deadly storm on the way back from a supply mission to a remote post in northwestern Greenland he felt personally responsible for. So Wegener was no longer around to champion his idea, which was drawing mostly critical attention at the time. Some of the criticism against him was unwarranted, either based on the perception of a scientific outsider to geology taking on a geological hypothesis, or there was prejudice based on his having fought on the losing side of World War I. More reasoned specific arguments included that the continents didn't really fit when you matched current shorelines together. We know now that continents don't end at their shorelines, but extended out to the edge of the continental shelves where the slope increases, and Wegener was insightful enough to match his continents at these continental shelves about 200 meters deep offshore. That's where he found his match, and that's a point we agree with him on today and disagree with the past geologist who rejected the match. Wegener even hinted that the apparent rise in the center of the Atlantic Ocean was a place of new crustal formation early in his work, but he lost that thread, which we are going to have to pick up again next episode. Who knows if he was still entertaining or came back to this primitive idea of seafloor spreading in his last diary, which is with another victim of the 1930 Greenland expedition. A subsequent rescue mission found Wegener's body, but not the man who was traveling with him. Rasmus Vilmussen buried Wegener in the ice, marking the grave with his skis, took Wegener's diary, and wandered off to die himself. He and Wegener's last scientific journal are still frozen in the Greenland ice somewhere. Derek Ager more recently said, geology is like the life of a soldier, consisting of long periods of boredom, punctured by short periods of terror. After Wegener died and everyone could more easily beat up the ideas of a dead guy, Continental Drift languished until the next terror of World War II. We will continue our story with battles at sea in our second episode on the theory of plate tectonics as we unravel seafloor spreading, here on Earth Explorations.